Hey everybody, Vade here, and this is going to be hands down one of the most challenging problems we'll ever see on the channel, just because of the amount of work that's there and the attention to detail that is required is going to be pretty high. So I really don't want to make a small mistake here, because a lot of this is just testing your algebra skills. But also the integral that you get at the end here is going to be pretty tricky as well. And the reason why I'm bringing up integral here is because we're going to have to evaluate a definite integral, because this is area under the curve, and we use definite integration in order to find area under the curve using FTC principles. So I'm going to start off with what I find easiest first. So I see this determinant here, determinant of a 2 by 2, remember, right? If this is A, B, C, D, determinant of A would just be AD minus BC, so it would just be 6 times 6 minus 5 times 7, so 36 minus 35 is 1. Okay, and I'm just going to put A equals 1 and highlight it. Okay, so I can remember here. Now if we go to f of x here, and we're gonna have to integrate f of x. I see this 2. I'm gonna deal with this guy right here. We have x e to the natural log of 2 root 3 sine of pi over 3. So sine of pi over 3 is root 3 over 2. So we have 2 square root of 3 times root 3 over 2. The 2's will cancel, and we get 3. So then 2x e to the natural log of 3, that would just be 2x cubed. So we'll get 2x cubed here. And then this is dot product, vector dot product. I proved this on the channel, understanding, not memorizing. Go watch it. So this is x1, y1, x2, y2. So this will just be x1, x2, so 5 times 5 minus y1, y2, right? So x1, x2, x1, x2 plus y1, y2. So this will then just be 25 minus 24, which will then just be 1. So then 1 times x is x. So we'll just get x here. And then here we have a summation. So this is, of course, geometric series. I see that the rate here would be 0.5, but I just need to find, and that's, of course, if we want to justify here, 0.5 is greater than -1 and less than 1, so this does converge, in fact. But our a sub 1, and the formula for that would just be a sub 1, where a sub 1 is the first term in the sum, over 1 minus the rate. Between each like all the rate, for each term, like for example, like 0.5 is the rate, so it'd be times 0.5, then times 0.5, then times 0.5. That would be the rate. So in this case, the reason why this does kind of trick you if you know that, like, you think this is in the a sub 1 times r to the n minus 1, standard form of a geometric sequence, but it actually isn't. This here 4 is not a sub 1 because we're starting at 2. So just in order to find a sub 1, we just plug in 2 here. So just be 4 times 0.5, so 2 minus 1. So 4 times 0.5 to the first. So that's just 4 times 0.5. So that's 2. I think, right? 4 times 0.5. That's 2. So it's just, so 2 is our first term, so it'll just be 2 over 1 minus then 0.5, so I'm just going to do 1/2, so it's just 2 over 1/2, which is 4, and then we have an x here, so we'd have 4x, and then here, x squared minus sine squared x minus cosine squared x, I'll just be x squared, and we can factor out negative sine squared x plus cosine squared of x, Pythagorean identity, so that'll just be 1, so x squared minus 1. Okay, so now we're down to this equation here. It's a cubic. So what I'm going to do is I'm going to use like some principles, such again, because I'm assuming this is no calculator, so I'm thinking Descartes rule of signs, rational roots test. So I'm going to try 1 first. I'm going to try the easy ones. So I'm going to try like 1. So then we'll get 1, -9, 27, -35. I'm just doing synthetic division here, and we want the remainder to be 0. So 1, -8, and then we get 19. Okay, yeah, this won't work. So I'm going to try 5. That'll just be 1, -9, 27, -35, 1, 5, -4, -27. Okay, this does work. So remainder of 0. So then B will equal 5. B, so 5 is one of the roots. So we have B equals 5. And now look what it says here. We have to kind of take this into context here. So it's saying only the positive roots of B. And I assume, because we're going to deal with real numbers, because we're doing definite integration, we're trying to find actual area under the curve. So I'm not going to waste my time solving this quadratic here with x squared or b squared minus 4b plus 7. I'm just going to assume that they're just going to be either complex, imaginary solutions, or they're going to be like negative. That's what I assume, okay? Because if we had multiple b values that were positive, then it wouldn't make sense in the context of the picture. Okay, so with that in mind, I'm going to write out the integral here. So it's going to be the integral from 1 to 5, right, of 2x cubed plus x over 4x plus x squared minus 1. We're going to do this with respect to x. All right. So now what I want to do here is I just want to, again, I know obviously u sub will not work here, but I do want to just set this equal to u for just a second so I can see what type of algebraic manipulation I'm able to do here. So I'm going to do u equals to 4x plus x squared minus 1. So then du will equal to 2x plus 4 dx, right? What is that? 2x plus 4 dx. So that's just going to be 2 times x plus 2 dx. So what I want to do here is I want to get this in terms of x plus 2. So I'm gonna do like a small manipulation technique here. So I'm gonna do plus 2 minus 2. And then I'm going to use properties of integrals to kind of split this up. So I'm going to get one integral from 1 to 5 of x plus 2 over 4x plus x squared minus 1. And, of course, we can evaluate this here with the u substitution. But then I'm going to do minus 2 integral from 1 to 5 of 1 over 4x plus x squared minus 1. Right, x plus 2 over 4x plus x squared minus 1. Then minus 2. Again, I'm just checking my work as I go. I'm trying to see if it's matching up. I don't want to make a simple mistake here. Because I have not solved this problem yet. This is my first time solving it. I'm solving it with you guys. So minus 2 integral from 1 to 5. The same denominator, then plus 2 integral from 1 to 5 of x cubed over the same 4x plus x squared minus 1. So I'm going to deal with this first. So we set u equal to this, so we'll have, and again, here's what I'm going to do. I'm going to do u1, u2, because our bounds, I'm going to get them in terms of u eventually. So we'll get x plus 2. We're going to draw an arrow here. X plus 2 over u times du over 2 times x plus 2. So then the x plus 2's will cancel, and then we'll get L at 1/2 natural log absolute value of u2 minus ln absolute value of u1. Okay? Right? That should make sense. So now with this right here, this is gonna be a little tedious. So I'm gonna I'm gonna move this out here. So then we'll get. I'm gonna first complete the square in the denominator. Now, from what this looks like, this isn't gonna be an arctan situation, but I think it's gonna be partial fractions situation here. So what I'm gonna do here is I'm gonna first do the completing the square. So I'm gonna do 1 over, then this will be x squared plus 4x, plus 4 minus 4 minus 1. So that'll just be 1 to 5, 1 over x plus 2 the whole squared minus 5 dx, right? X plus 2 the whole squared minus 5 dx. So as I said, this isn't an arctan case, because if we do the square root of -5, that'll be imaginary, and that just won't make sense. We can't do anything with that. So what I'm thinking here is I'm not gonna use u here. I'm just gonna, just for clarity, I'm gonna set v equal to or x plus 2, and then of course dv equals dx. So I'm gonna have integral from v1 v2 of 1 over v squared minus 5, and this will be dv. And then so now I'm gonna use difference of two squares in the denominator, and I'm gonna get this to v plus root 5 times v minus root 5 dv. And so now I'm going to use partial fractions decomposition here. So I'm going to say that this right here the integrand equals to a over v plus root 5 plus b over v minus root 5. So if I do this here, then I'm going to get 1 equals to a times v minus root 5 plus b times v plus root 5. So now we just need to set our v values. So I'm going to say, like, if v equals positive root 5, we see that the a cancels, or the a, it's times 0, so a is not there. So we get b equals 1, right? Root 5 plus root 5 is 2 root 5, so 1 over 2 root 5. Okay, and I've got, again, no need to rationalize here. But so we'll get 1 over 2 root 5. And then if I let v equal negative root 5, if I do that, and of course we're going to solve for a here, right, because the b times 0 cancels, so we're going to get negative 1 over 2 root 5. 2 root 5, right? Negative root 5 minus root 5 is negative 2 root 5, so negative 1 over 2 root 5. So now we're going to rewrite this here as integral v1 v2 of negative 1 over 2 root 5 over v plus root 5 plus 1 over 2 root 5 over v minus root 5 dv, right? It's the same thing, and we justified that through partial fractions decomposition, right? Yeah, that looks correct. So then we'll get, I'm going to first, we can do valuation bar. So we'll get negative 1 over 2 root 5 ln absolute value v plus root 5 plus 1 over 2 root 5 ln absolute value of v minus root 5 from v1 to v2, right? Yeah. Okay, so we have this right here, and I'm going to again highlight this, and I'm going to highlight I'm going to highlight this as well, and I'm going to highlight this as well, so then we can get our u-bounds. So now we have this guy right here. Now this guy, I'm going to do some polynomial long division here. Okay, so I'm going to have 4, I'm going to rewrite it as x squared. I'm going to rewrite the standard form. So 4x, or x squared plus 4x minus 1. Right, x squared plus 4x minus 1. And then we have the x cubed. And if it helps you, you can write the 0x squared, you know, there as well. But you don't have to. So I'm going to do, x squared, or x cubed, divided by x squared is x. So then we'll have, if we multiply here, we'll get x cubed plus 4x squared minus x, right? X cubed plus 4x squared minus x. We subtract, and we get negative 4x squared plus x, right? Right, negative 4x squared plus x. So now we're going to do negative 4x squared divided by x squared. That's negative 4. So then we'll get that times the x squared plus 4x minus 1. We'll get negative 4x squared minus 16x plus 4, right? I'm just going to check that. Negative 4x squared minus 16x plus 4. So now we're going to subtract here, and we just get 17x minus 4, right? Yeah. 17x minus 4. So now we're going to integrate this, right? We'll have one more thing here. I don't know why I kept this. This is fine. This right here, this v thing should be times a negative 2, right? I'm going to rewrite this here, times negative 2, right? That's a linkage error, so this is what we're dealing with here, okay? Right, negative 2 and times that guy. So now if we deal with this integral here, we'll have 2 times the integral from 1 to 5 of x minus 4 plus 17x minus 4 over x squared plus 4x minus 1. Yeah. Whew. 1 to 5, x minus 4 plus 17x minus 4 over x squared plus 4x minus 1. Seems right. So now we'll have 2 times, I'm going to do this big thing right here. I'm going to evaluate these integrals like x squared over 2 minus 4x, right, using power rule from 1 to 5, right? And then plus this integral right here, the 1 to 5, 17x minus 4 over, and I'm gonna do the, actually, no, never mind, x squared plus 4x minus 1 dx. I'm going to actually use this guy here again, the u substitution. I'm going to use a different letter or variable just in case, or just for clarity. So I'm going to, if I let w equal to x squared plus 4x minus 1, then dw equals to 2 times x plus, what, 2, what was it, 2 times x plus 2 dx. Right, so I want to get this in terms of x plus 2. I want the numerator to be x plus 2. So what I'm going to do here is I'm going to factor out a 17. So I'm going to factor it out like 17, 1 to 5 of x minus 4 over 17 over this denominator here. Right. And then now what I'm going to do is I'm going to do the plus 2 minus 2. Right? The plus 2 minus 2. So now we'll just get, and again, this looks like a 12. 17 times integral from 1 to 5 of x plus 2 over x squared plus 4x minus 1, which we did already solve. But I do want to just write it down. And then minus 4 over 17 minus 2. Minus 4 over 17 minus 2 integral from 1 to 5 of 1 over the x squared plus 4x minus 4 over 17 minus 2 integral from 1 to 5 of 1 over x squared plus 4x minus 1 dx, which we already solved as well. So now this right here, we got ln absolute value of u1. So I'm going to just do 17. And by the way, for this, forgot to mention here. Oh no, we didn't even need a valuation bar there. So we got W2. So ln absolute value of W 17 times 1/2 ln absolute value of W1 W2 minus ln absolute value of W1 and then minus 4 over 17 minus 2, and then we evaluated this integral right here. Oh my god. Yikes. Okay, I'm going to use the v plus 5 thing. You know what? Just for clarity, I am just going to remove the w here. And I'm just going to keep the u substitution. I'm going to write here, use same u and v sub, right? Because these are just repetitions. So I'm going to rewrite this as just u2, u1, and then minus 2 times, this will then be negative. Actually, no, I think, what was this from? Yeah, minus 2, we included the minus 2. So yeah, we don't have to write a minus 2 again. Negative 1 over 2 square root of 5 ln absolute value of v plus root 5 plus 1 over 2 root 5 ln absolute value of v minus root 5 from v1 to v2. Whew. Okay. And so that's this guy right here. I'm trying so hard to be organized here. But this is going to be challenging. Oh my god, that's not even it. That's not even it. We still have this guy. plus 2 times. And again, the way I'm solving this is probably very inefficient. This is just what came to my head on how to do this. But hopefully what I'm doing is so far correct. Yeah, it should be a parentheses right here. Okay. So it should be, I'm going to use a bracket here. Square bracket. And yeah. These are our 3 components. And I'm not even going to simplify this because that's just arithmetic stuff. I want to get a numerical answer down. So it's going to be like this. Minus this, so plus that. It's going to be all plus, right? Plus. I'm going to use a different color for that just to show kind of like the transition. Like this is what we're doing. So this would be like this, plus that, and then plus that. So I'm going to, and again, a lot of this is substitution because once we know this guy, we can get this guy out of the way and save space. Because a lot of this is just repetitive. So for U1 equals to just, I'm going to do U2. U2 equals to, if we do 5, so 4 times 5 is 20. 20 plus 25. 45 minus 1 is 44, right? 44. Right? Make sure I do this correctly, right? 4 times 5 is 20. 5 squared is 25, so 25 plus 20 is 45. 45 minus 1 is 44. Great. So then U1, right, we plug in 1 and get 4 plus 1 minus 1. So that's just 4, right? 4 times 1 is 1. 4 times 1 is 4. Plus 1 squared is just 1. So 4 plus 1 is 5. Minus 1 is 4. So this will then just be ln 1/2 ln absolute value 44 minus ln absolute value 4. Okay, I'm gonna stop. I'm gonna erase the highlighter here, and I'm gonna highlight this. And so now, if I put my substitution here, this should be, again, just trying to stay organized as much as possible. So this should be 44 and this should be 4. And now with this here, I'm trying to figure out how to be organized here. Okay, this integral right here. So first of all, what is V1 and what is V2? So I'm going to solve V2 first. So V2 equals to, what is our V? V2 is 1 to 5. So V2 equals 7 and V1 equals 3, right? V2 equals 7 and V1 equals 3. So this guy is just going to be, negative 2 times negative 1 over 2 square root of 5 ln absolute value of 7 plus root 5 plus 1 over 2 square root of 5 ln absolute value of 7 minus root 5 minus, oh my god, negative 1 over 2 square root of 5 ln absolute value of 3 plus root 5 plus 1 over 2 square root of 5 ln absolute value of 3 minus root 5. Okay. All right, I think we can write down what we have. So the area M so far, so 1/2 ln 1/2 ln absolute 44 minus ln of 4 minus 2 times, and I'm actually gonna just move this here. I'm not gonna rewrite this. I'm gonna move this, and here's smart. Minus 2 times that, and then plus 2 times, and then this will just be FTC 3 squared over 2 minus 4 times 3. I'm not even going to simplify that simple one. 3 squared over 2 minus 4 times 3 minus 1 squared over 2 minus 4 times 1. 3 minus 1 squared over 2 minus 4 times 1. And then that plus 17 times 1/2 ln absolute value 44 minus ln absolute value 4. And then this guy minus 4 over 17. I'm going to use brackets. Well, this will be brackets, and I also want to use brackets inside here. Minus 4 over 17 minus 2. And then I'm going to copy and paste this guy here. I don't want to write that. It's just going to be this. Times this guy right here. And then close bracket. And then close bracket again. So yeah, I think this is our answer. I think this is it, and I'm not going to simplify this. Now, again, I think I chose a really tedious way. I don't think that this is obviously the best way to do this. The reason why, again, it probably isn't that hard of a problem, at least this integral. There are better shortcuts with this. But this is what I got. Now, let me know if I'm missing something here. Now, of course, if you probably maybe used a better way, like a better shortcut or something, because I'm sure you could probably do this in a much shorter time. I'm just using the stuff that I know integration-wise. to do this. But if you do have the time to check this, please do, and let me know about any errors. But this is what I got. I'm sure there's a simplified answer out there. So if you want to kind of cross-check this, then feel free to do that. No pressure, but at least maybe catch a mistake I did, at least with the integration like technique. But I think everything is fine. I think I'm 85% sure. Hopefully the work matches up. This was a tough problem. Just a lot of stuff. You had to be organized here and pay close attention to, the details. So yeah, I'll see you guys in the next one. Crazy video.